is a friend who many of us know in the room, who was the President's Science Advisor and the head of the Office of Science and Technology Policy in the prior administration, and had a good deal to do with shaping the space program over the last few years. And I speak, of course, of Jack Marburger. Jack, it's a pleasure to have you with us, and the podium is yours.
Great, thanks, Norm. It's a pleasure to be here and talk about these events that occurred for me 6 years ago when the Chief of Staff, Andy Card at the time, pulled together a group to propose concepts for the long-term future of the U.S. human space exploration program. During that process, the Chief of Staff formed a group we called the Rump Group that consisted of a number of people. I will list their names in a written document that I'll provide to the committee so you have a complete record of that early history. But as a result of recommendations by that group, the Chief of Staff's office formed a set of questions that they sent to agencies, including NASA, Department of Defense, the intelligence community, and some others, whose answers guided the policy from then on. And the process occurred under the normal policy committee, coordinating committee process, PCC process, and the process was augmented by representatives from NASA, particularly, and from the intelligence community. And I sat in on all of those meetings, all of the senior policy meetings in the White House during that period. Out of this process emerged the President's address of January 14th, 2004, and the accompanying policy document called A Renewed Spirit of Discovery. Two features of that process are noteworthy. First, it took place in an unusually rich environment of information. We had numerous reports, studies, commentaries on all aspects of space exploration, reaching back to the 1952 Collier's Magazine series by Werner von Braun, and including work of predecessors of this committee, including a previous Augustine Committee report. Second, the final policy document was a compromise between contrasting policy perspectives offered by NASA and by the White House advisors. In presentations to Congress and to the public, NASA representatives emphasized the NASA point of view, subsequently, which began to appear even during the policy process through leaks to the media. In my own public presentations, and particularly in two speeches I gave in 2006 and 2008 to the annual Robert H. Goddard Memorial Symposium, I emphasized the White House view. NASA decisions following 2004 tended to diverge from the compromise vision toward greater emphasis on a Mars expedition as a primary objective, and minimizing the features of sustainable cumulative capabilities and commercial participation that were important parts of the vision. NASA decision-making did grow increasingly constrained by real budget shortfalls, created in part by the larger than estimated return to flight cost of the shuttle. But it would be a mistake to assume that the actual development path for space exploration since 2004 has accurately reflected the overall concept of the vision. In September 2003, partly in response to the questions to agencies that I mentioned, I drafted my own version of the policy direction then emerging from the deliberations of the Rump Group, and it remains my own personal preference today. And so I would like to continue my presentation by simply reading you that document that I prepared in response to these questions. First question was, what is our vision for future space exploration? Our vision is to understand as far as humanly possible the universe beyond Earth's immediate vicinity, and to use that knowledge to improve the quality of life in every aspect for all people. We will pursue these goals through every means appropriate to the diverse tasks of the enterprise, with respect for the health and safety of those involved, and in balance with other worthy endeavors. Why is it important? Within the Earth's orbit, space exploration has enabled technologies for national security, economic gain, and science. Surveillance, navigation, communication satellites are now part of our military and civilian infrastructure. Scientific satellites looking deep into space and down at Earth are changing profoundly our notion of the substance and structure of the universe and the operation of the Earth environment. These will continue to bring benefits for the foreseeable future. Beyond Earth's orbit, we have sent robotic explorers to every planet in our solar system except Pluto. Each planet and moon visited has yielded new scientific discoveries and challenged our understanding of planetary formation and the possibility of emerging life. Imaginative schemes have been proposed for further enhancing our national security, economic strength, and scientific knowledge using objects and phenomena accessible only from space. Those that require large structures beyond Earth's orbit are impractical today. If such schemes are ever to be realized, the groundwork must be laid far in advance of their implementation. Laying that groundwork is the task of our generation. 3, what contribution does human spaceflight make to this vision? The reference is to the current spaceflight activities. With one exception, it does not contribute in a tangible way to the immediate task of preparing for large-scale development of space resources. That exception is the understanding of the effects of weightlessness on humans. In the future, humans working with robotic systems will probably be required for large-scale development, such as the construction and maintenance of remote facilities, mines, factories, base stations. We do not now, however, possess the knowledge or technical infrastructure necessary to deploy humans safely beyond Earth's immediate neighborhood. Human spaceflight does contribute to society in non-tangible yet compelling ways. It provides lofty goals and promotes human orientation toward acceptance of our place in the universe. Human space exploration has inspired an entire generation of Americans to pursue careers in mathematics, science, and engineering. And U.S. leadership in human spaceflight serves as a highly visible example of how we can apply advanced technology towards peaceful ends. It provides a vehicle for international cooperation and a uniquely positive legacy to future generations. Why is human spaceflight important in the long term? Future desirable large-scale operations in space, such as resource exploitation, climate control, solar energy schemes, will probably exceed the capacity of robotic systems for independent operations. Under these circumstances, human participation can be justified and will likely be required. Until the costs and risks of human participation are better understood and controlled, however, the establishment of goals for such large-scale operations is a futile exercise. The necessary human-oriented studies, which involve placing humans in a weightless environment, can be carried out simultaneously with continued robotic exploration throughout the solar system. Most official studies of human spaceflight conclude that it has value that might be called spiritual or existential. No agreement exists as to what this means, but it is complementary to the value of some kinds of scientific knowledge. We do not study the collisions of galaxies for commercial profit, but understanding such exotic phenomena brings them into the human domain. In the same way, knowing that men and women have visited an exotic world literally humanize those places. Heroic acts and their importance to society are real, and spiritual motivations are among the strongest that we have. Much anecdotal evidence suggests that space exploration provides a vehicle for these social benefits. Programmatic options. Run the gamut from terminating human spaceflight altogether to announcing an Apollo-like sprint to Mars. The options vary in the degree to which humans participate directly, that is, physically, in space exploration. At one extreme, space exploration is entirely robotic. At the other, vast resources are invested to maximize human participation. A balanced approach would prudently build capability for human exploration beyond low Earth orbit, while avoiding premature commitment to specific large-scale operations. By careful planning, we can make each step a foundation for a range of next steps, so with time our investments mount, costs and risks diminish, and we keep options open to exploit the right one when we're ready to make a big move. As cost and risk are lowered, the case for human presence in space improves, and the variety of plausible missions increases. We have a vigorous and highly productive program of non-human space operations for science, military, and commercial purposes. The philosophy of going step by step and preparing for the future on a broad front introduces human capabilities only as appropriate, keeping in mind that the ultimate goal is to permit humans to operate routinely on missions where they are needed. The quest to enable all large-scale missions is itself more ambitious than anything yet ventured in space. It includes careful exploration of the moon, for example, and establishment of a base there for in situ resource utilization. This should suffice to capture the public imagination. Our programmatic vision for human spaceflight is to bring the successive spheres of every space frontier within our reach, to diminish the daunting cost and risk of every expedition into this new territory. We can embark upon this mission now because every future mission is encumbered with the same impediments of cost and risk. Reducing risk. Radiation and the effects of low gravity limit the duration for humans to live safely and work in space. The radiation can be simulated here on Earth, but to study weightlessness requires a free-fall laboratory, and we have one, the International Space Station. This is the first existing step, and we aim to build upon it with our international partners. The Earthbound and the space-based work together will provide the data and the ideas that we need. They build stepping stones of knowledge about ourselves that we will need to survive in space. Reducing cost. Some strategies are well known. Miniaturize, improve materials, develop better transport systems, and forge partnerships with robots and with able nations. Other strategies are technically less mature but offer much greater potential payoff. Make heavy parts beyond Earth's deep well of gravity to cut the cost of lifting out to space. And where should we find the raw materials for this? On the moon. This requires a moon base, robotic, and ultimately human crews for oversight. Some consequences of this approach. It optimizes not for a single mission, but for the steady accumulation of technologies and capabilities that provide a base for multiple operations. It emphasizes the role of robotics, of ground-based research, and of system thinking. It places the International Space Station in a larger context. Its purpose is specifically to acquire knowledge that allows us to protect humans in space. This approach is compatible with a reduction of the current human spaceflight program. The current program places humans in space to accomplish missions that with today's robotic technology can be accomplished without them. The result has been to decrease resources available to build the foundation toward future missions for which humans have a more important role to play. We cannot place humans deeper in space for any length of time without solving the problems of risk and cost. The first order of business is to solve these problems, not to use humans in lieu of robots in the safer low Earth orbits. The approach entails extensive robotic exploration of the moon, potentially followed by the construction of a permanent lunar base whose objective is resource exploitation, possibly for economic gain, and to use the material to facilitate further expansion of human exploration deeper into the solar system. This program would be carried out simultaneously with research into the mitigation of human risk factors and the development of new launch and transport technology. schedule, and budget. The pace of advance will be dictated by the level of resources devoted, but a range of budgets permits continued progress. Close cooperation with and even reliance on international partners should be seriously considered. No date should be established for humans to return to the moon or Mars. The rate of advance away from the Earth should be dominated by budget and technical progress, and by no calendar but the winding of the planets along their eternal paths. Well, I wrote that to try to educate and persuade as well as to explain. If I were rewriting this today, I'd add a paragraph on the role and importance of commercial space enterprises and emphasize the importance of sustained effort. And some of that deficiency was remedied in the final version of the policy, but it's been neglected in execution. Let me restate a plea that I made in my 2008 Goddard lecture. If the architecture of the exploration phase is not crafted with sustainability in mind, we will look back on a century or more of huge expenditures with nothing more to show for them than a litter of ritual monuments scattered across the planets and their moons. In my opinion, the all-encompassing scope of the vision we advanced was diminished in the final policy by specific mention of Mars as a target, and the immediate path forward was burdened by deadlines and difficult budget issues. Our view was pragmatic and conservative with respect to human operations, but vast beyond any scenario since von Braun's view, in its view of a future in which the entire solar system is open to the service of humanity. Thank you, Mr. Chairman.
Beck, thank you very much for those comments. And I wonder if we could get a copy of your paper for our committee.
I have a longer version of this that I will get this afternoon.
That'd be terrific, so we could distribute it. We have time for a couple of questions from my colleagues. Does anyone have any questions they'd like to start out with? Please, Chris.
Thanks very much for your remarks. I'd like to ask you to be a bit more specific with respect to your comment on sustainability. Do you view the current architecture, the program of record, as a sustainable architecture, or would you prefer to see that modified in some way?
It's hard to characterize the current program because it has been impacted so much by exigencies and budget constraints. So it's not clear that what's being done is consistent with NASA's intent or with any particular policy intent. So I want to be a little careful about how I say this. Certainly, the sustainability has a lot to do with what society can tolerate, and how to carry a vision like this beyond administrations. We have supportive administrations, and we have less than supportive administrations. We have recessions. We have booms and busts. And I think it's important to craft a strategy that is not disrupted by those exigencies. And in order to do that, you have to be somewhat careful about establishing firm deadlines and rushing to achieve them. In my view, the most important factor here is sustaining the workforce that has the expertise required to build the various pieces and to continue an initiative over a period of a century. I don't know whether the current mission is sustainable in that sense. My guess is that not sufficient attention has been paid to the sustainability dimension of the program. There's a lot of fixation on how to achieve the short-term goals of the International Space Station. There's a lot of attention fixed on the gap, which in the grand scheme of things is not as significant as we make it to be. So closing the gap as a short-term objective tends to get in the way of the longer-term thinking.
Anyone else? Bo?
Thank you very much for your talk to us. It was very useful. My question is this. If you look into future and consider an undertaking like going to Mars for humans, it's going to be terribly complex, very difficult, and very expensive. And the question is, you didn't say much, how would you envision engaging international or global participation in it, and how would you do it? And would you invite people to be on critical path of this undertaking? Give them an important role where they feel like they're stakeholders.
Of course, the concept of a step-by-step program that establishes infrastructure that can be utilized by subsequent missions. For example, simply putting up communication satellites around the planets that you'd like to visit in the future reduces the cost for those subsequent missions. That's a good example. It will certainly work for Mars. It will work for the Moon. And in a vision like that, there are many things to do. There are many concepts that need to be filled in and parts of the system that different nations can participate in. And while the Europeans, for example, take advantage of communication satellites that we have around Mars, we can take advantage of infrastructure that's left by the Europeans or the Chinese or the Indians or whoever has the capability to put it there. But what we need is a shared vision for what the system has to look like. Power systems, for example, on the Moon. Somehow we have to get something up there that can generate power for industrial operations on the Moon, which we will need in order to reduce the cost of lift in future missions. So those are things that are not necessarily objectives that a single nation can achieve. All nations should be contributing in a way that is agreed can foster the continued accumulation of capability.
Jack, I had a question that's perhaps almost impossible to answer, but I think you had to do it in your prior job. And you've talked some about the trade-off between human spaceflight and robotics and balance and so on. How do you deal with the issue of trading, say, the space program against medical research or energy research, environmental research? How did you deal with that?
Philosophically, there is a way to do that, and I mentioned it in one of my Goddard lectures. The point is that in the vision that we advanced, the motivation was not the existential or spiritual motivation for human achievement. The motivation was national security, commerce, science. Not just putting somebody up there on a remote planet. Well, those are missions that can also be achieved by investments in other activities. And so you can weigh the impact of those investments. Now, the impact of space exploration, particularly human space exploration, is very long term. But at least you can get some sense of the domains of human enterprise that might be advantaged by it. Even the objective of encouraging young people to become scientists and engineers and so forth can be achieved in other ways. So I think once you get back off a little bit from this notion that we must, as human beings, just be out there, then which is not, you can't compare that with anything, any other expenditure, so it's not possible. Once you back away from that, you get into spheres where you can compare. What's the advantage of having $30 billion invested in NIH, for example, versus investing $5 billion in an enhancement to a step-by-step program?
Yeah, Chris?
This is just to follow up on this very interesting discussion. How would you factor into that sort of scheme in a way that would be comparable, the advantages of, saying, conducting fundamental research in cosmology?
Well, the fundamental research in cosmology is in a different category. That's in the category of, we are human beings, we live in the universe, we must know about it. There is an urge to do that. And there are some questions that are intrinsically very interesting. Whether or not intelligent life exists elsewhere in the universe is an extremely interesting thing that humans ought to be interested in and willing to spend something on. The origin of the universe is sort of an intrinsically deep and interesting question that humans have spent a lot of brain power on for a long time. And similar things, the ultimate structure of matter. We're spending billions of dollars on particle accelerators to determine the structure of matter, which has essentially no impact other than its spin-offs on human, on enterprise, commercial enterprises and human health and so forth. But it's an intrinsically interesting question. So it's hard to say. In my view, those kinds of questions are more intrinsically interesting than the issue of having a human being on a remote planet, which doesn't, you don't get too much out of that except for the pride of knowing that human beings can do that. And whereas the knowledge that you get from studying cosmology and so forth is a permanent knowledge. Many people can share in the enterprise of getting it and thinking about what it means and so forth. Whereas I view the flags and footsteps model as having less impact in the long term.
Jack, thank you very much for sharing your thoughts with us. We appreciate it. It's great to see you again.
My pleasure. Thank you.
Take care.